Hello students from the Schoolship Gann in Stavanger, Norway. In particular, TIP students, Technical Industrial Production. Today we're going to look at how an engine works. We're going to focus on particularly the parts of an engine, but first we sort of have to understand an engine and how it works. Well, here is a nice picture of an overhead cam engine, talking about the cam shaft is over the head of the engine. But let's just look at what we say in English. We say, repeat after me, internal combustion engine. Remember, we went through the words interior and exterior. If you have interior paint, it's on the inside. If you have exterior, it's on the outside. Well, internal, we talked about internal body parts. Combustion, that means kaboom. It means some sort of lighting on fire, igniting. And then engine. Now, what do you call this thing that's in a car that makes it go really fast? You say forbrenningsmotor. So you say in Norwegian motor, and we say engine. Now in English, there's a big difference between what an engine is and what a motor is. We're going to talk about that in just a second. But also, think on the ship. You say machine room, and we say engine room. Now, there's a big difference in English between what an engine is and what a machine is. So I want you to be aware that we're using different languages to say the same thing, but they mean different things in English. Okay, so now internal combustion, which means there's something inside, locked inside, and it's exploding. An engine. Can you think of other examples of something that's locked inside, where the explosion is locked inside, exploding and doing some work? Well, you have a bullet, for example. Here you have the combustion locked inside of the chamber here. You have a firing pin which hits and ignites the gunpowder, and it produces work of throwing the bullets out the barrel of the gun, right? So now, to understand the basic idea behind a reciprocating combustion engine and how it works, it's helpful to have a good mental image of how internal combustion works. One good example is an old Revolutionary War cannon. You've probably seen these in movies where soldiers load the cannon with gunpowder and a cannonball and light it. That is internal combustion. But it's hard to imagine that this simple engine has anything to do with a car engine. Well, a more relevant example might be this. Say you took a big piece of sewer pipe, cloaca, maybe 3 inches in diameter and 3 feet long, and you put a cap on one end of it. Then say you sprayed a little WD-40 into the pipe and put in a little drop of gasoline. And say you stuffed a potato down the pipe, like this. Now, I am not, students, recommending that you do this, but just say that you did, right? Well, you'd have what's called, commonly, a potato cannon. Okay, so again, we have a cloaca, we have a sewer pipe, we have it closed with a cap at one end. We put a little WD-40, a little smøreolje in there so the potato can go in and out easily. And then we put a little gas at the one end. And then we introduce a spark, right? We need to ignite the fuel. And what's interesting, and the reason why we're talking about this device, is the potato cannon. It could launch a potato about 500 feet through the air. Now, the potato cannon you see here uses the basic principle behind any reciprocating internal combustion engine. If you put a tiny amount of high energy fuel, like gasoline, in a small enclosed space and ignite it, an incredible amount of energy is released in the form of expanding gas. You can use that energy to propel a potato 500 feet. In this case, the energy is translated into potato motion. You can also use it for more interesting purposes. For example, you can create a cycle that allows you to set off explosions like this hundreds of times per minute. And if you can harness that energy in a useful way, well, you have the core of a car engine. So almost all cars use what is called a four-stroke combustion engine. Four-stroke combustion cycle in the engine to convert gasoline into motion. The four-stroke approach is known as the Otto cycle, in honor of Nicholas Otto, who invented it in 1867. The four strokes are illustrated here. Okay, you have the intake, and then you have the compression stroke, the combustion stroke, and then the exhaust stroke. Okay, so you can see in the figure that the device called a piston, right, here is the piston. The piston replaces the potato in the potato cannon. The piston is connected to the crankshaft and by a connecting rod. So here's the crankshaft, and here is the connecting rod connected to the piston. So as the crankshaft revolves, it has the effect of resetting the cannon. So here's what happens as the engine goes through its cycle. The piston starts at the top, and then the intake valve opens. And the piston moves down to let the engine take in a cylinder full of air and gasoline. This is called the intake stroke. Only the tiniest drop of gasoline needs to be mixed into the air for this to work. Okay, and sometimes you have a fuel injector which atomizes, which breaks up the fuel and mixes it with air so it burns really nicely and cleanly. Then the piston moves back up to compress this fuel and air mixture. Compression, which means squeezing it tight together. Compression makes the explosion more powerful. Part 2 of the figure, right? So in a diesel engine, you don't have a spark plug. It's just the compression itself which ignites the fuel. Now, when the piston reaches the top of its stroke, the spark plug emits a spark to ignite antenna the gasoline. And so then the gasoline charge in the cylinder explodes, driving the piston down. Once the piston hits the bottom of its stroke, the exhaust valve opens, right? And then the exhaust fumes go out and leave the cylinder and go out the tailpipe eventually. And now the engine is ready for the next cycle. So it takes another charge of air and gas. Notice that the motion comes out of an internal combustion engine is rotational, right? It's going around and around. While the motion produced by the potato cannon, well, that is linear, going straight back and forth. So in the potato cannon, it's going back and forth, straight, linear. But then in the combustion engine, it's going around and around, rotational motion of the crankshaft. But this rotational motion is nice because we plan to turn or rotate the car's wheels with it anyways. But then can you think of what is an external combustion engine? Do you know, we talked about now an internal combustion engine. What is an external combustion engine? Have you got an idea? Well, it's actually a steam engine, right? So a steam engine in old-fashioned trains and steamboats and steamships is the best example you can think of for external combustion. The fuel, whatever you want to use here, lighting the fire, you have coal or wood or oil, burns outside the engine, and then it heats the water up to create steam. And this steam creates motion inside the engine. Here it's lifting a piston. And it creates work. It turns out that an internal combustion engine is much more efficient. It takes much less fuel to make the ship or the car go per nautical mile or kilometer than the external combustion engine. Plus, an internal combustion engine is a lot smaller than what you would need to have a steam engine. So that's why we don't see any cars or ships these days using steam. Okay, so now I want you to notice the difference here in English. An engine, as we've just seen, is any machine designed to convert energy. So we're taking the energy of gas or fire or coal or gunpowder and then making that into mechanical work, getting something done with that energy that's in the coal or the gas or the gunpowder, making something happen. Now, what's a machine then in English? Well, machine is a tool or an assembly of interconnected components or parts. And let's just look at that. An engine could be simple as a bullet. You've only got 3 parts, the actual cylinder, the gunpowder, and the bullet put together. Okay, so it doesn't need to be complicated at all. Same thing for a machine. It can either just be a simple tool, as you see here, or it could be an assembly of interconnected components, parts, that are arranged together in order to transmit force or modify force in order to perform useful work. So when you say machine in English, you're thinking of a big complicated engine. For us, a simple machine can be a wedge. This is the simplest machine you can possibly have, where you're using it to transmit or modify force rather than having a blunt hit against the wood. You have an angle and it creates much more force than if you had a blunt force. Okay, a plane is the same thing. It makes your work easier by being able to push it up at an angle. Same thing with a lever. So a machine could be something in English as simple as a tool which modifies force. For example, here you have a pulley or even a hammer. Here's a lever, the claw end of a hammer pulling up a nail. That is in English a simple machine. Okay, so then motor, you're saying förbränningsmotor. Well, what is a motor in English? Well, we use the word motor pretty much just, I mean, there's other definitions, but when we're talking about a motor, we're generally talking about a machine that converts electrical energy into mechanical energy by means of the forces exerted on a current carrying coil placed in magnetic field. Okay, let's not get too complicated. Just think in the internal combustion engine, you have a start motor, for example. You have the battery hooked up to the start motor, and when you want to start the car, you turn the key, and the start motor pulls on the timing chain, which gets the process of combustion going. So that's using electrical energy to convert it into mechanical energy, into work. That to us is a motor, an electrical machine, converting electrical energy into work, mechanical energy. So I really want you to notice a difference in English between these 3 words. They're very key. Okay, so now we're going to look at the parts of an engine. Well, here we have the engine block. Now, an engine block is usually cast from one solid piece of metal because you have some high forces of combustion going on here, and you don't want it breaking apart at the seams. Some, I believe, in Norwegian. So usually it's machined from one piece of aluminum or steel, some high quality steel. But we call the base of that an engine block. Now, you can write in your workbooks what you think this is in Norwegian. Do you know what it is in Norwegian, what we call this? Motorblock. Motorblock. Right, so again, you're using motor instead of engine. Okay, and now on the top of the engine, goes the cylinder head. Now this goes on top of the cylinders. Now inside of the cylinder head you've got the camshaft. And now to let in the gas and the air and to let out the exhaust you need to have valves. Now the cam on the top here is moving the valves. So you've got the intake and the exhaust valves, and you have, they can't, if they're going down they need to come back up, so they have springs and lifters. And so you can see here lifters and the springs, and the valves actually go inside of the cylinder head. Okay, you say cylinder top eller cylinder holder. So that's pretty straightforward. Okay, and then you can see cylinders. This is a V8, I would imagine. Yes, we have 4 cylinders. It's a V-line engine, 4 on this side and 4 on the other side. Cylinder, that's almost the exact same word, just the C in English, S in Norwegian. Okay, and then the big workhorse of the engine, the crankshaft. Now, the crankshaft is the piece that is taking most of the energy produced of the engine and turning it from the up and down reciprocating energy into the rotating energy going on here. What do you call a crankshaft in Norwegian? Vevaksel. Vevaksel is the key word. Right. Okay. And then what's connecting the piston to the crankshaft is what we call the connecting rod. Here we have the big end, is what we generally call the big end of the connecting rod connected to the crankshaft, and the smaller end going to the piston. Okay, that's called the connecting rod. What do you call that in Norwegian? You can go ahead and write it down. Stempelstang. Stempelstang. Okay, great. And then we have the piston itself. You have piston rings, the O-ring that goes around here. And the whole point of the rings is to keep the oil going up and down the cylinder so it has good lubrication. We can get more into that later. You call that a stempel. Stempelstang, stempel, piston. Okay, let's go to the next one. And then the spark plug. This is what gives us our source of ignition. It lights the fuel in the chamber or the cylinder. In Norwegian, spark plug, you call that a tennplug. Great. Good. Okay. And then I told you some cars, most cars these days have a fuel injector rather than just letting in the carburetor before would bring in fuel and air. But now a fuel injector is going to atomize, is going to make the fuel into small little tiny droplets mixed with air so that it burns cleaner and better and more efficiently. So we say fuel injector. Now what do you say for that? Do you know? Go ahead, write it down. Disa holder. Disa. Disa. Right. Okay, and then as I said, to get this combustion going, this internal combustion in this chamber, you need to let in air. And you have to have gas as well. But this is the intake valve. So it's going to lift up and it's going to let air come into the chamber. So intake valve, and what do you say in Norwegian for intake valve? Inløpsventil or innsugningsventil. And then the opposite on the 4th stroke, when we need to let out the exhaust fumes, you need to open up this valve here, the exhaust valve. And in Norwegian you say exhaustventil or utblåsningsventil. Okay, you just go ahead and write that down. Great. And then we talked about the camshaft. The only way that you can get these valves to open and close is you have the crankshaft connected to the camshaft with a timing chain. And then you see these little lobes, cams on the camshaft. They actually lift the lifters that lift up these valves, and then they have to have springs so that they close again. So the camshaft then lifts the lifters, which lifts the valves, exhaust and intake valves, perfectly timed to open at the right time. And so it's connected to the crankshaft by, oh, you call this a cam axle, camshaft, cam axle. So it's connected here. You can see a little cog. It's connected to the crankshaft through a timing chain. So here is actually the camshaft cog, or we say it's a sprocket, and here is the crankshaft or the flywheel. Okay, so that's the timing chain. Okay, and you say registerskjedde, registerskjedde. Okay, so now can you identify the cylinder? We're looking at a diesel engine this time. I know it's a little different than a petrol engine, or a gas engine, we say in American English. Now we're looking at a pretty good size B&W diesel engine on board a serious size vessel or ship. You can see the size of the person over here. But can you identify the cylinder in this picture? Yeah, it's not too hard. It's number 1 here. Okay, so there is the cylinder. Okay, how about the piston? Can you identify the piston in this picture? Well, yeah, if you have the cylinder, you have the piston, but actually it's 2 here. Here you have a cylinder as well and a piston, a half view of it there. So yeah, there is the piston. Great. And now in this picture, we're getting another view of another engine, looking at it from the side view. Can you identify the crankshaft? Where in this picture is the crankshaft? Right, it's down here is the crankshaft, okay? So then, where is the connecting rods? Then, where is the connecting rods? Well, this is a diesel engine, so it's a little different. You have what's called a piston rod. Here you actually see, instead of in a regular car engine, you have just a connecting rod connecting to the piston. In a diesel engine, you have a connecting rod, and that's connected to the piston rod, and that's connected to the piston. So it's a little different in a large diesel engine. But the camshaft then, where would the camshaft? You still have intake and exhaust valves, and it depends if it's 4-stroke or 2-stroke. But in this engine, there is actually a camshaft that's lifting up the valves. Can you identify the camshaft? Where do you think the camshaft is? Yeah, it's up here, right? Number 20. Okay, excellent. And now what about the exhaust valve? Do you see where the exhaust is coming out? Right, it's, yeah, up here, right? Because we're going to have the turbocharger. We're going to take that excess heat coming off the engine and using it to heat water for accommodation. Lots of, you can heat up the fuel, the bunkers, to keep the fuel nice and warm if you're using heavy oil. And you can see here is the intake for the air coming in on this side. Okay, so now I'm not going to get too complicated here. We're going to be watching a movie shortly, and they're going to be giving you these 2 terms. They're going to go through the engine parts that I just explained to you, but then they're also going to be talking about compression ratio. So I want you to learn what that is about, and then in Norwegian it's called kompresjonsforhold. So that's a common term used in the engine department. And then we have engine displacement. Engine displacement is when we talk about the size of an engine, 2.4 liter. What does that mean in Norwegian? Slagvolume. Okay, so we're going to watch a movie now and try to pick up exactly what these 2 terms refer to. We'll come back to it later. Don't worry about that. Okay, here we go. Let's watch the movie.
We're going to explore some technologies that Toyota uses to maximize engine performance and economy and reduce emissions.
First, we'll review the basics of how an engine works and some basic engine terminology. An internal combustion engine needs air and fuel to function. The more efficiently an engine breathes, the more efficiently it will produce power. Now we'll look at the basic components of an engine. The main components of the engine are the engine block and cylinder head. The internal components of an engine include cylinders, the crankshaft, connecting rods, pistons, spark plugs, fuel injectors, intake and exhaust valves, camshafts, and a timing chain or belt. Power is produced in the engine by the four-stroke process. As the piston moves on its first downward stroke, the intake valve opens to allow a mixture of air and fuel to fill the combustion chamber. This is called the intake stroke. Next, the intake valve closes and the piston moves on an upward stroke that compresses the air-fuel mixture. The compression of the air-fuel mixture will make it combust with greater force than if it were uncompressed. This is called the compression stroke. Third, the spark plug ignites the air-fuel mixture, causing it to burn explosively, which forces the piston into another downward stroke. This is called the power stroke. The fourth stroke is the exhaust stroke. As the piston begins its second upward stroke, the exhaust valve opens and the burned air-fuel mixture is forced out of the combustion chamber through the exhaust valves. Two terms you may be asked to explain to customers are the engine's compression ratio and displacement. Compression ratio is the ratio between the total volume of a combustion chamber and cylinder when the piston is at the bottom of its stroke and when the piston is at the top of its stroke. In this example, the compression ratio is 10:1. Higher compression ratios produce more power but require higher octane fuel than engines with lower compression ratios. Engine displacement is how the internal size of an engine is described. It's measured as the cylinder bore times the length of the piston stroke. This is multiplied by the total number of cylinders and is usually expressed in liters or cubic centimeters. For example, a 2.4-liter four-cylinder engine has a total displacement when adding together all four cylinders of 2.4 liters. The number of valves that engines have varies. Older engines tend to have one intake and one exhaust valve. Some engines have two intake and one exhaust valve. Most high-performance engines use two intake and two exhaust valves. The opening and closing of the valves is performed by the camshaft. Some engines use one camshaft with rocker arms and/or push rods actuating all of the valves. If the camshaft is above the valves, it's called a single overhead camshaft or SOHC engine. When an engine uses a separate camshaft for the intake and exhaust valves mounted above the valves, this design is called double overhead camshafts or DOHC. All Toyota engines use double overhead camshafts. Most four-cylinder engines, including all Toyota four-cylinder engines, are an inline design. Engines with more than four cylinders typically have the cylinders arranged in a V configuration. All Toyota 6- and 8-cylinder engines are V-type engines.
Okay, we'll continue this next time. Have a great rest of the day. Bye-bye for now.